Hi, everyone. Thank you for joining our Manufacturing and Distribution Industry Forum at the Data and AI Summit. I'm Michael Ortega from the Industry Marketing team here at Databricks, and I'll be your host today. We have an amazing group of leaders from Databricks and John Deere with us to share their perspectives on how organizations in the industry are using data and AI to create more resilient supply chains, improve yields through smarter factories and machines, and anticipate and meet customer demands. With that in mind, I'm excited to hand it off to our first speaker today, Rob Saker.
Welcome and thank you for joining this session on data and AI in manufacturing at Databricks. My name's Rob Saker. I've worked at Databricks for 2 amazing years where I lead the retail and manufacturing industries. I come to Databricks by way of industry, having held various leadership roles at multiple companies, ranging from CDO to leading transformations. But Databricks is really a passion for me as I'm able to help companies solve the problems I once struggled with. The best way for me to introduce Databricks to you, if you're new to Databricks, is to explain that we think of ourselves as the data and AI company. And what we mean by this is we provide a single data platform that allows you to unify your data engineering, analytics, and AI workloads. Our company roots were established by the creators of Apache Spark, and we've extended this with other open source technologies like Delta Lake and MLflow. Our cultural dedication to open source and open standard tools is something that you'll hear me talk about throughout today, and it really remains at the core of our mission. And I don't want to gloss over the fact that we've got over 5,000 customers in just about every industry across the globe. So what are those customers in those industries? Well, we have customers ranging from the very largest firms to the most innovative startups. One of the best parts of my job is I can get to work with companies with hundreds of thousands of data scientists working on massive problems at scale. And then the very next call will be talking to a startup dealing with computer vision or autonomous drone delivery. Databricks works well for all ranges of company sizes. The largest companies have faith in being able to process petabytes of data and complete the most advanced models, while the startups know that they can start with a small project and scale and use the same architecture as they grow. So as I was preparing for this session, I was trying to think of what event best typifies what we've been dealing with in industry over the past 18 months. And there's been a lot to choose from. And, we've had civil strife, forest fires, droughts, and more. But to me, the ever-given getting stuck in the Suez Canal was the defining moment of the past 18 months. No matter how efficiently you run your business, you couldn't anticipate this. And external events are driving more and more of the disruptions that are impacting our business. Think about this. Near the end of the year and into this year, we saw increased delays due to port blockages. The Port of LA in the US saw ships at anchor for 8 days waiting for a berth. We're dealing with chip shortages from Asian fabrication plants, and those shortages are causing delays in auto manufacturing around the globe. Shipping costs have spiked. Part of the challenge in shipping is finding drivers who are vaccinated and willing to drive. Spot rate shipping from Asia to other parts of the world has also skyrocketed. But the Suez Canal situation also highlighted the power of data and AI to me. On the day the canal blockage was announced, we shared a link. I posted it on LinkedIn to a notebook that we provided that enables companies to quickly determine the effects of delays and compare that versus rerouting. We allowed customers to take what was a complex task that would have taken weeks and do it in hours. The Databricks 30 is an index of the top 30 publicly traded companies, customers across industries. We found that this group outperforms the S&P 500 by 21 percentage points on the alpha, which measures relative performance of indexes. What do these leading data and AI firms do that others don't do? They manage and react to volatility better than their competitors. Nobody could predict the Suez Canal blockage, but the best firms were able to immediately assess the impact of rerouting and make the decision on whether to reroute or not. Being able to immediately respond and make smarter decisions may not seem like a big factor for any single decision, but these small decisions add up. And this is why I believe you start to see a separation in our comparative indices right around the time of lockdown. If you wanted to build a portfolio of high performance stocks with low risk, building around data and AI leaders would certainly give you a fantastic portfolio. Now, here's some more information on the Databricks 30 composition. Not only does it outperform the S&P 500 in overall performance, but has a beta, or a risk factor, of 0.97, which is less volatile than the S&P 500. Data and AI-led companies generate stronger returns more rapidly and with less volatility than the S&P 500. Now, we don't release the companies that comprise the Databricks 30, but they're equally weighted across our 5 top industries. Many of these companies are traditional industrial era companies, proving that data and AI isn't just a tech company feature. In fact, we found that when we removed tech companies from the index, the performance actually increased. And this is the key learning really from the past 18 months. Speed matters. Speed means being able to analyze situations faster or respond to changing business conditions or provide more relevant information in the moment. The other observation I've seen in working with firms is that the difference between haves and have-nots is increasing. Legacy companies focus on what happened. Data and AI leaders focus on why did it happen, what will happen, how can we make it happen? Now, this isn't the future. This is today, and it has been for a lot of the leading data and AI firms. Manufacturers that focus on the red circles are generating millions and hundreds of millions in increased revenue and savings over their competitors. And all of those red circles require data and AI. Data and the best application of it matters more than ever before. Organizations that figure out how to effectively use all their enterprise data to fuel innovation will be the ones that take part in the data and AI-driven economy of the future, which McKinsey estimates will add $13 trillion to the global economy by 2030. We don't even have to go out that far into the future to understand the impact of data and AI. It's already happening. Clearly, data is playing a central role in both our professional and personal lives, while artificial intelligence is being exponentially infused in more of our daily digital interactions. This includes credit cards, growing food, online shopping, the creation of pharmaceuticals, and even finding life on Mars. The design and execution of the right data and AI strategy that clearly aligns to corporate growth goals is absolutely crucial to ensure that companies that want to be relevant in tomorrow's economy will be. So it's not surprising that many industry experts are now saying that data is the most valuable asset in the modern economy. However, the explosion in data availability over the last decade, combined with low-cost storage, compute, and machine learning environments, has caused a major shift in how organizations leverage data and AI to drive future growth and manage risk. Data within the enterprise is growing exponentially, and enterprises are placing increased demand, interest, and importance on data and machine learning on their future successes. These aren't years out, with 98% investing or having active data-driven AI projects. That said, successfully using data and AI to generate meaningful and measurable business outcomes remains a challenge for many. 73% of organizations still struggle with big data and AI initiatives. When looking at AI use cases only, McKinsey found that only half of organizations have successfully adopted AI into one business function. So with all this interest and investment, why are we still struggling in this? Well, a lot of it has to do with using the wrong tools for the job. Let's go back in history a bit. Data warehouses are great for providing consistency, enterprise class security, and data governance, and they're really designed to serve BI reports. They're highly optimized to serve BI. But being highly optimized for BI means that they're actually suboptimal for doing things like data science and machine learning. And unfortunately, most modern data warehouses today lock customers into one vendor. Conversely, data lakes are great for machine learning. They're inexpensive and can handle multiple formats of data, but they have poor support for BI They're complex and they lack the enterprise governance tools that most companies need. So what we've done is to merge the strengths of these two approaches into a single platform. We invented this concept. We published a white paper on it about a year ago, and the concept has really taken off. We call this the lakehouse architecture. It gives you the ability to build curated data lakes that are reliable, performant, and with the governance you expect from data warehouses directly on top of your existing data lake. Provides you reliability from asset transactions so that you can be sure that your operations in the data lake are either fully succeed or fail. You have the ability to rewind and time travel and to understand every change made to your data. And with advanced compression and indexing to improve the speed and performance of queries. And finally, Delta Lake supports fine-grained access control list, ACLs, to give you much more control over who can access what in your data lake. Now, the Databricks Lakehouse platform is unique in three ways. It's simple. Data only needs to exist once to support all of your data workloads on one common platform. It's open. It's based on open source and open standards to make it easy to work with existing tools and avoid proprietary formats or vendor lock-in. And it's collaborative. Your data engineers, analysts, and data scientists are able to work together much more easily. This is the manufacturing lakehouse. And really, the idea is that we want you to bring data from any source, whether that be from shop floor or historian systems, deploy devices in the field, enterprise tools like SAP, or external data sets in any structure or frequency, managed with enterprise class data management features and organized for extremely high performance to enable all personas equally and are available across any cloud. So what do I see next for manufacturers over the next 12 months? From a general trend, one of the biggest overall industry developments is what I call the move to equipment as a service. Manufacturers are increasingly moving to service-based models to manage risk for customers. And this opens up new revenue streams. Customers have realized that the maker of equipment is often better prepared to manage the maintenance of that equipment than they are. And we've seen this in examples across the industry, ranging from airplane engines, elevators, tires on vehicles. I've even seen this on bakery equipment. So why is this? Well, first, equipment as a service offers numerous benefits to both customers and manufacturers. For customers, they're promised improved reliability, efficiency, and yield from equipment. They're also able to have more organizational flexibility through less specialized resources. Now, the downside for customers is that they pay more in variable cost per hour for the use of that equipment. What about manufacturers? Well, equipment as a service opens up new revenue streams for them. The information that they get from product usage and from maintenance is useful for them, not just in maintaining that equipment, but also in developing digital twins and being used for future product design. The downside for manufacturers in this model is that they assume greater financial risk from the uncertainty of how that equipment's being used. So how can manufacturers effectively manage that risk? They manage it with data and AI. Now they're able to bring in sensor data from equipment and other usage information directly from devices. They enrich this information with environmental data that helps them to understand better the context of where this equipment is being used. This can be anything from weather to adjust settings on turbines, humidity, heat, and cold temperatures to automatically adjust plant settings to improve optimal yield. Traffic and road condition data can be brought in to be used to understand transmission and maintenance on fleets. Even pollutant and smog information data like air particulate can be used to better understand engine wear and tear. Now, another major investment for manufacturers is sustainability. And this is something that's a bit of a passion for us at Databricks. Databricks has been leading data and AI innovation and sustainability for years. It's really important for us. We recently held a global sustainability forum with leaders across leading sustainability organizations. Beyond that, our customers are using our thought leadership and leveraging our free tools that we publish to create index funds, improve efficiency in their decisions and operations, and make better decisions today on sustainability. And I'm proud to say that we're dragging our industry forward. Our competitors have increased their mentions of ESG by 57% in just the past 90 days. Some say imitation is the most sincere form of flattery, but we don't mind. While we don't like vendor lock-in, we are all locked in on this planet together, and anything that we can do to improve is good. So we're going to continue investing in sustainability and encourage our industry partners and competitors to do more. But be sure to follow us for continued thought leadership and innovation in this area. What are some other popular use cases that we're seeing with manufacturers right now? Well, certainly IoT and the smart edge is foremost among all of our customers' minds. We've seen that explosion in the number of sensors that are being deployed both on the shop floor and in the field. This rich information is coming in real time and needs to be acted on quickly. Item level forecasting is also another really hot topic area for manufacturers. It's no longer sufficient to manage items at the batch level. Manufacturers want to be able to predict which parts will be used with greater accuracy. Item level forecasting can easily lead to savings in the millions and hundreds of millions of dollars for manufacturers. Digital twins is another hot topic that comes up in a lot of my discussions. The reason for this is easy. Manually testing new equipment or the impact of reconfiguring lines in plants is a timely and expensive process. Our customers are using Databricks to create digital twins that can be used to simulate these potential changes in product design or line configurations before they're enacted. And they can do this many times a day versus the weeks or months it takes to do things such as device simulation with physical devices. All these varied use cases and many more are being solved by Databricks customers today on that lakehouse pattern. Let's drill into the preventative maintenance use case, because this is a really hot topic. When we talk about preventative use case, this can refer to anything from equipment on the shop floor, ATMs, commercial vehicles, energy plants, and much, much more. At the center of preventative maintenance is this concept that we call the potential failure curve. The potential failure curve, or PF curve, is used to highlight when we think a device is going to fail and when we should perform maintenance on that device, or if that device is in a part of a sequence on that line. As we move from left to right on the curve, we move from preventative to reactive maintenance. You'll notice on this curve that the actual failure of a device begins early in the process. It's earlier than we could predict or observe. Now, modern preventative maintenance algorithms can predict the failure of that device fairly early in the process. It can predict it earlier than even skilled detection. Now, even with skilled detection, we're able to perform maintenance in a reactive mode before critical failure on the entire device. When it gets to the point where anyone can observe the failure of equipment, the equipment's in a severe state of disrepair. And this typically leads to performance losses or even catastrophic results. Our goal with preventative maintenance analytics is to understand when failure is going to occur with enough time to allow us to proactively schedule our maintenance windows and avoid unplanned outages. Now, one of the enhancements to preventative maintenance windows in recent years has been the introduction of unstructured data sets that help us to understand usage of equipment. This may be anything from using sensor vibration data to images of products coming off the line, to auditory recordings, to more traditional readings such as temperature, pressure, or oil readings. AI allows us to use all of our senses to observe how equipment is performing. But think back to that PF curve, that potential failure curve. It's our goal in that curve to understand as early as we can when a device is likely to fail so that we can proactively manage and plan the downtime of that device or line. The more information is delayed, the more we move into a reactive and unplanned downtime. Now, the challenge with legacy approaches is that they process information in batch. What batch means is that we are processing data only every few hours per shift or even day or days. This delay moves us rightward on the PF curve towards reactive. One of the advantages of Delta and the lakehouse pattern is it allows us to stream data in real time so that current data is always available for analysis. Now, not only can we perform algorithms for predictive maintenance with current data and no delay, we can even start to perform anomaly detection on streaming data as it happens. Now, this is an example of how information gets processed through Delta. We land our data in the data lake in what we call bronze tables. Bronze tables are unprocessed raw data from our source systems. Even at this point, we can perform anomaly detection on the data. We next move to silver tables, and we do filtering, cleansing, and enrichment of data. Silver data is where we typically perform our robust machine learning processes. It's still highly atomic data at this point. And if we want to support BI, we can perform summarization and further enrichment and bring it into gold tables. You can connect your BI tools directly to Delta, or you can have your data warehouses load directly from the gold table. In fact, many data warehouses can read Delta tables natively. But as you can see, as we move from left to right, we perform our functions, and those functions take time. Data in bronze can be available in real time. Data in silver can be updated in streaming or batch. And gold level aggregations tend to be on more of a batch process. But if you're doing real-time analysis, you want to be using this medallion architecture approach. So the next question that I hear when we talk through this is, well, won't that skyrocket my usage costs? And not necessarily. This is an analysis that a customer of ours did comparing Delta to popular cloud-based data warehouses for IoT stream ingestion. Now, I apologize, this is in Swedish krona, but the ratios are still about the same when you convert them with currency exchange. What they found was that with Delta, their costs were about 1/3 what it would take in a cloud-based data warehouse. Now, it may not be immediately intuitive, but one reason for this is the fact that when you stream data, even though you're streaming in far more frequently, it doesn't require as large a cluster as when you do it in batch. And then this customer also found that certain use cases that they wanted to do in real time were available on the bronze layer. And more advanced analysis such as k-means clustering were available in silver. But neither of the real-time or advanced analysis were available on the cloud-based data warehouses. In fact, information needed to be further extracted from the cloud-based data warehouse before they can perform data science on this. And those egress fees added to the cost of the cloud-based data warehouse. This is one example. There's another customer of ours that published a blog on this on Medium. If you go search for Gusto in the UK, they wrote a great article about moving from cloud-based batch data warehousing processing to an event-driven architecture on Delta with similar results. And before I wrap up, I also want to make people aware of free tools that Databricks provides to help companies accelerate their journey with data and AI. First, our solution accelerators, which may be our most popular program. And I'll get to this in a second. Next, we have a world-class business value organization that helps companies build business cases, map value, and prioritize their roadmaps to accelerate the realization of value from data and AI. And while Data and AI Summit may be the largest event that we organize annually, we also host executive summits, industry forums, and hundreds of other meetups, webinars, and other events throughout the year. Again, check out Databricks.com for the latest. Now, on Databricks Solution Accelerators, we know that doing data and AI can be hard. It requires an intimate understanding of the business problem, current and emerging methods, and design patterns on how to solve the problem. In some cases, people don't even know that a problem is possible to solve. As Databricks has worked with thousands of customers across a variety of industries, we've noticed a lot of these recurring business problems. This can be anything from how do I better predict demand for my products? How's my company being measured in the area of sustainability compliance? When should I perform maintenance on my lines? We created solution accelerators to help our customers show how they can solve these business problems with data and AI and provide them with a solid foundation from which to build full solutions. Now, solution accelerators are not full solutions. They're not black boxes. They're perfectly, they're well documented and open. They're not proprietary. We use open libraries, and they're not just snippets of code. These are fully functional fast starts that help demonstrate how a company can ingest data from a wide variety of sources in batch or streaming, in structured, unstructured data, transform and prepare that data for analysis, inspect the data, develop and test models, and deploy the output to downstream systems. Beyond just educating our customers, they're a foundation from which companies can accelerate their own initiatives. And these are built based on extensive research and development, and they leverage leading practices in the areas of data engineering and data science. And they've all been optimized to take full advantage of the performant nature of Databricks. We take pride in our solution accelerators. They're developed by industry experts with decades of experience, and they're being widely adopted by hundreds of customers. This even includes some of our most advanced data science customers. These aren't just for beginners. Now, we love these because they help us teach our customers how to quickly design and implement patterns to solve their pressing problems. We have nearly 40 current solution accelerators today, with many more in active development. And again, these are free. Go check out Databricks.com. You can read the blog posts on these, download the notebooks into your own environment and play with them, watch video walkthroughs, and more. If you want to learn more or stay up to date on the latest manufacturing news at Databricks, check out these additional resources. First, the Databricks blog is the best place to get a wide range of information: new products, features, updates, and solution accelerator announcements. And secondly, you can also follow me on LinkedIn. LinkedIn is the first place that I post links to new announcements. I want to thank you for your time today. I hope you enjoyed this session.
Thank you, Rob. That was great. Now I'm excited to welcome our speakers from John Deere to discuss how they're executing on their smart industrial strategy powered by AI and the tremendous value it's delivering back to their business. Take it away.
Hello, we're super excited to be here and talk a little bit about what it looks like building a smart industrial future with data and AI at John Deere. My name is Jake Sankey, and I lead the product direction and engineering for our enterprise data and analytics platforms.
And my name is Greg Finch. I work at the John Deere Intelligent Solutions Group. John Deere has a long and proud history of innovation. From the very beginning, our employees have been creating solutions that have revolutionized farming again and again. John Deere, he was our founder, a blacksmith and a farmer who lived in Vermont. In the 1830s, many farmers were moving westward, and John followed and settled in Illinois. There, he learned an important lesson about farming that we continue to learn all the time today. And that is that what works well in one part of the world may not necessarily work everywhere. John's problem was that his cast iron plow that he was accustomed to using didn't work well in the sticky Midwest soils that he was working in. Every few feet, he would have to stop and scrape the mud off the plow and then resume plowing and then do it again. Being a blacksmith, he recognized that using a plow with a more polished surface would likely lead to better results. And so he took a discarded steel saw blade, polished it up, attached it to a plow, and it worked wonders. And the rest is kind of history. It was a huge success. Farmers from all over started asking him to build a self-scouring plow, as he called it, and our company was born. In the 184 years since, John Deere has consistently adapted to changes in customer needs, advances in technology, and new business opportunities. And the problems that our farmers face today are not getting any easier. There is an ever increasing demand for food and for fiber. The demand for food is driven largely by population growth and also by increased incomes of people in many parts of the world. At the same time, our customers are looking for ways to do things differently, and especially in ways that are more sustainable for the future. I'll never forget the first time I visited a customer farm. This was over a decade ago, and we were up in upstate New York. Um, and I don't know if we planned it this way or if it just happened, but we arrived just before lunch, and we got invited in and sat down at the kitchen table and had a fantastic meal. Farm fresh, homemade everything, and we loved it. We also had a very interesting conversation with the farmer. He was a brilliant man. Many of our customers are. He had multiple degrees from MIT. He was an inventor, an innovator, and just had lots of ideas of how to improve his farming operation. One of the things that he said to me really sticks out. He said, you know, the problems that we deal with in farming are not that different than the problems you deal with in manufacturing. We want to do more with less. I want to eliminate waste. I need my inputs where I need them, when I need them, at the right time, at the right quantity. I need to avoid excess inventory. And when I go to harvest my product, I need my distribution channels set up to deliver the product. He was comparing it to lean manufacturing, and his idea was that if we could focus on his production system and make it as efficient as possible and as smart as possible, he could be more successful as a farmer. This past summer, our company announced a bold new direction. We call it Smart Industrial, and it's a way of it's a new operating model for the company and a new business strategy.
This new model is really a foundational and fundamental shift across all areas of our business. It affects everything from manufacturing to precision ag solutions to IT, and it helps us to run leaner and faster and introduce new technologies and get them in the hands of our customers quicker. It also makes sure that our future and priority as a company are aligned with the priorities and futures of our customers. It helps us to unlock new value for our customers, getting things to them quicker and helping them be more successful and profitable. And at the core of this strategy is data and AI. For us to continually advance and make our machines even more intelligent than they already are, the only way we'll be able to achieve it is to fully embrace data and AI. If we're able to do that and stick to it, we're going to be able to continue solving some very challenging, but also some really cool problems.
So there are three key areas that we focus on in the Smart Industrial strategy. The first one I've already mentioned, production systems, a focus on production systems. We look at a production system as the way that our customers get work done. It encompasses all of the jobs that they do, all of the decisions they make, all of the data they analyze in order to grow their crop or to complete a project. All of these jobs and decisions form a complete system in which one job or decision influences the next. And so by dedicating and orienting our company around our customers' production systems, we can begin to think about our business the way they think about their business. And we can find opportunities to help them be more efficient, save on expenses, increase productivity, and become more sustainable. The second area is called lifecycle solutions. John Deere products are legendary for their quality, longevity, and the support they receive through our dealer networks. We have no intention of relaxing our aftermarket commitment to our customers. So we've integrated all of our aftermarket and support capabilities to more effectively and efficiently manage our customers' equipment, service needs, and technology needs through the whole lifetime of the John Deere product. The last area is the one we're most excited about. Jake and I work in this space, and that is the technology stack.
Our technology stack is really vast, lots of different pieces to it. And this is what enables us to make smarter machines and more productive machines. It consists of onboard and offboard components. On the onboard side, we have sensors, tons of them. We have vision systems, guidance systems, and wireless connectivity. Offboard, we have cloud infrastructure and storage and scalable services that allow us to receive and process and analyze all of that data. This stack is what enables us to help our customers be more productive and more successful. To kind of bring it to a tangible example of how our data, AI, and the technology stack come together, I want to look at our new X9 series combine. This is the most advanced and powerful combine we've ever made. This is designed with large acre farmers in mind. So these are customers that have a lot of ground to cover in a short period of time. And the X9 is absolutely packed with integrated technologies. It delivers 45% more harvesting capacity while using 20% less fuel than just our previous generation. And the X9 features things like artificial intelligence, computer vision, machine-to-machine communication, and integrated sensors for connectivity and self-driving capabilities. If we dig a little bit deeper, let's take a look at Combine Advisor with Activision. This is one of several precision ag technology options available for the X9. With this system, cameras monitor continually images of the grains down to individual kernels as they're taken up the combine's elevator and dumped into the tank. We use machine learning to analyze grain quality and automatically adjust the operating parameters of the machine if any damage is detected to the grains, and we do it all on the fly. There's additional cameras as well, and they monitor the debris from the operation, things like stalks and leaves and cobs, as they're ejected out the back. This ensures that no grains are being ejected, which helps our customers minimize their losses during the operation. Then if you take something like this and combine it with another system like our AutoTrack precision guidance system, the machine is able to automatically and precisely navigate rows in the field while the Combine Advisor automatically adjusts and operates operating parameters, which helps the customer not only minimize losses, but also maximize their yield. As we continually make our machines smarter and smarter, we generate more and more data, and we'll talk more about that in a minute. With all of this data, we're able to gain a lot of valuable insights from it to help us make better business decisions and more valuable insights back to our customer about their operations. We can then find even more insights and make more decisions when we're able to bring that data together with the data from other systems within the company, things like sales, financial, parts, dealer, and engineering systems. This is really difficult when we have a strategy that we're really focused on data and AI to further advance our products. If all of the data is siloed, difficult to find, it's hard to get started with new analytical projects and trying to find insights. To meet this need, we've built a cloud-native data platform. It's built around a data lake architecture, so we get those benefits of data lakes around flexibility and scale. But we've built numerous services and capabilities around the lake to enhance the experience for our data scientists and analysts to be able to discover and access data consistently and not have to wonder where to find data or how to use it. And all of that in a very scalable platform that allows them to scale up their analytical workloads easily. By enabling this for all of our practitioners, we're able to gain more insights, build more models, and then leverage those insights and models in customer and dealer-facing applications within our internal business and within our equipment itself. There's no shortage of use cases for data and AI in any business. And at Deere, by bringing our data together in a discoverable and scalable platform, we're enabling our supply chain, manufacturing, engineering, marketing, and financial services to benefit from data and AI to improve their decision-making and our customer experience. In our aftermarket and customer support channels, we're proactively supporting our customers, leveraging product, service, and warranty data together with our connected vehicle data. And our precision ag analytics warehouse within our data platform. This enables analytics pros across the company to discover and leverage this vast and super valuable data at scale.
So we're going to talk now about a few challenges that we have faced in building our data platform and scaling it to the amount of data that we have arriving today. You can see it from this chart that the growth in the amount of data we're ingesting from our machines is tremendous. It doubles to triples every year, and we're projecting even more growth in the future. I think back over my career, I actually had a kind of interesting intersection with our data platform. Even before I started working for John Deere, this was 20 some years ago. I was a senior in college, just about to graduate. And I was looking for a job, and I found this little tiny company that was advertising a position, and I called them. And they said, "We're so excited. We just landed a big contract with John Deere. They're going to start sending data from tractors through satellites, and we're going to receive that data and we're going to store it." And I was like, wow, that sounds cool. Satellites, that's awesome. And then I thought, why in the world would John Deere send data? What data? These are tractors. I had no concept of where we were headed with data at John Deere. I arrived at the company and started to learn more about the project. And they told me, I asked, how are we going to store this data? And they said, oh, it's no problem. We're just going to put it in Microsoft Access. And I just thought, okay, cool. That sounds perfect. But if I look at, where we're at today, and I just kind of laugh at where we started all the way back at Microsoft Access. Over the years, we have had to evolve our data platform many, many times. We've been through mainframe databases and multi-sharded mainframe databases, and ultimately we got to the cloud. And even since we've been on the cloud, we've reinvented the data platform at least 3 times. And that's just the nature of dealing with large scale data. I worked with a colleague once. He was a consultant, and he made a statement that I think is pretty spot on. He said, in anybody I've worked with large scale data problems, every order of magnitude, whenever the amount of data you're ingesting grows by another order of magnitude, it's time to take another look at your data platform design. And that has held up pretty consistently for us. As we look to the future, we're already starting to look at what changes next. What are we doing next? You might wonder, where does all this data come from? Tractors are massive data producers. They do a lot of amazing work, but they also record an awful lot of data. This is a picture of an ExactEmerge planter. These machines are amazing. The tanks on the back hold the seeds. You can see tubes running out to what we call the row units. Those are vacuum tubes that are pulling seeds down. And then each of the kind of black circle things you see on the back of the planter are the mechanisms that do the planting. Also in that space are lots of sensors, and each and every single row unit has sensors that are measuring things like how many seeds were planted, what was the rate, what was the seed spacing, how deep was I planting, what's the ride quality like, how smooth am I going across the ground, and many other things. At the same time, the tractor in the front is pulling the planter, and it's recording all kinds of other things about its performance. What's its temperatures, what's its pressures look like, what are its fan speed, how much time is it spending in each gear, things like that. All of that data gets packaged together and sent up to the cloud. We receive it often at 200 millisecond intervals, so every 5 hertz we're receiving it. Sometimes it's more, sometimes it's less, but it all amounts to a tremendous amount of data. One of the places that data gets routed to is the enterprise data lake that Jake introduced. And we have a warehouse in the lake called the Precision Ag Analytics Warehouse. Here we store all of the sensor data. We have one table, one single Delta Lake table that stores trillions of records and takes up several petabytes of storage. That's all organized into dozens of layers of, you can kind of think of them as map layers. We can look at it geospatially and see what has happened in this space over history, as long as we've been recording. And that covers hundreds of millions of unique acres around the world. One of the really exciting things we've been working on this year is a machine learning feature store, which is taking all of that raw sensor data and producing, deriving new values or insights from it, and storing them in features that then can be used to train machine learning models. And that's something that is really something we're working toward in the future to really ramp up our machine learning in the company. And we don't expect it to slow down. There's a lot of drivers of growth. More machines are getting connected. We work in very rural areas, and connectivity is constantly improving in many places. There's more sensors being added to the machines. The data is getting collected at higher density, higher frequency, lower latency. And there's new things being put on the machines that are taking things like images and pictures now. And so we just see more and more drivers of data that will continue to send to our data platform. All of that leads to lots of challenges. The second challenge I'll just mention briefly is query optimization. As you can imagine, with a data set this size, partitioning is very important. The picture in the middle is a picture of what our partitioning looked like about a year ago, and it was way off. There's huge skew. We had some partitions that were way overpacked with data and others that held hardly any data. And our queries it was hard to predict how our queries would perform because of that. So we did a lot of work to reorganize the data. Time and space are critical for us. So everything is partitioned by time, by spatial keys, and by some business keys. The pictures on the left and right are a view of what our data partitioning looks like now spatially. You can kind of pick out from this where all the farming happens in the world. If you're interested in this one, there is a deep dive session in the conference specifically about this, how we've optimized our queries to work with this massive amount of geospatial data.
We all know that mishandling data can lead to some pretty severe damage for companies and the customers, reputations, trust, which takes us to challenge number 3 that we want to talk about, which is data security and data governance. This is truly a top priority for us. Anytime we're working with data, we have all sorts of data, sensitive business data, as well as customer data about their operations. To kind of tackle this problem head on, we've put together a centralized enterprise data governance council that has a global perspective, looking across all different data producing domains and regions of the world to understand the compliance goals and unique nuances within those domains. And they're the ones that kind of set our enterprise standards for our platform development as well as our analytics practitioners. In order to make that streamlined and try to enforce these standards as rules within our data pipelines, our approach was to build an advanced data catalog service around our platform that allows for discovery of data and also facilitates access requests to data and has automated workflows built in for approvals that strictly adhere to the standards that are set by that council. Before you ingest data into the platform, the data set needs to be registered. And part of that process is it has to be accurately classified from a variety of different data classifications. And once that's approved, ingestion can begin. Authorization to data, also managed in the catalog, is time bounded, and it has to be based on documented purposes and use cases. By us aligning closely with this governance council and evolving the platform as the standards evolve over time. We've been able to create visibility into what data is in the platform, who has access to it, how long they have access to it, and why they have access to it.
So those are a few challenges that we have faced. I'm sure many of you are dealing with some of the same challenges. We are super excited about where data and artificial intelligence can take us in the future. Just to give a quick glimpse of where we think that might be, we can look at one of our newest products that was just released a couple of months ago called See and Spray Select. This machine uses computer vision to identify specifically where weeds are in a field, and it controls each individual nozzle so that if it's spraying that field, it can pinpoint where the spray needs to go and apply the spray just exactly to the weed that needs to be treated. Um, which I think is just really, really cool. I've heard numbers. I think it saves something like 70% of chemical usage, which is a win for the customer. They don't have to purchase as much chemical. It's a huge win for the environment, not as much as being applied. And it's just a great thing all around. But I think there's an even bigger story here. And that is that to date, our machines have been super good at controlling themselves, like looking at what's happening inside the machine, monitoring everything that the machine is doing, and doing a masterful job of the work it's doing. But this is one of the first cases where the machine is actually looking outside of itself. It's starting to perceive its environment. It's looking at the weeds in the ground, and it's reacting based on that. And now just imagine all of the other things we can start to do as the machines become smarter about their surroundings, not just the weeds, but the plants that they're tending to, the soils. Maybe it becomes more aware of the weather, more aware of the fleet, more aware of the history of what's happened in this area, or more aware of what works well in this region. There are so many opportunities that we see with data and artificial intelligence at John Deere, and we think that the future is exciting.
Yeah, we're really proud of the legacy of John Deere, from steel plows all those years ago to these incredibly intelligent machines we have today. And we are super excited about continuing to push this industry forward and see how much more revolutionizing we can do for it with data and AI. We thank you so much for your time and hope you enjoyed hearing some about the things we're doing at Deere right now to innovate and change the culture of farming.
What a great presentation. Thank you for sharing your story. John Deere truly is ushering in a new era of farming powered by data. And that concludes our industry forum. Thank you all for tuning in, and make sure to stop by the Solution Theater to check out interactive demos on the most popular data and machine learning use cases in the industry. Enjoy the rest of the summit, everyone.